We're finally going to learn how to find the inverse now. So to find the inverse, we use the following formula. If matrix A is equal to this, A, B, C, D, then the inverse of A is going to be equal to 1 over A times D minus BC times by D, negative B, negative C, A. All right, let's really break this thing down now. Okay, first things first. We're multiplying this entire matrix by 1 over A times D minus B times C. What does that look like? Well, hopefully you can recognize that. That's simply the determinant, isn't it? So as you can see, AD is just A times D subtract B times C. So we're just subtracting the product of the diagonals there. That's the determinant. What else is happening? Well, as you can see here, I have DA. So originally I had AD, now I have DA. Do you see how they've swapped positions? Very interesting. What else has happened? Well, as you can see, I originally had C and B, but now I have negative C and negative B. So as you can see, they haven't swapped positions, but they've both become negatives. So by doing all of these things to the original matrix A, you create the inverse of A. You need to go 1 over the determinant, multiply that matrix now by first swapping the D and A and making both of these negatives. Now, what's happening by having this thing out the front is that this is multiplying each of the elements, okay? So this whole thing here is multiplying each of the elements here. So that means if we come here, see how I've got D over the determinant? And that's because this entire thing is multiplying with this entire thing is multiplying with that, this entire thing is multiplying with that, this entire thing is multiplying with that. That's how I'm getting each of these things here. So negative B times this is negative B on the determinant. Negative C times this is negative C on the determinant there, and so on. This is now the inverse. So those are the steps that you need to follow to get the inverse. Now let's read this here. Let's zoom out of it. And this is kind of just formalizing what we've just spoken about here. So to find the inverse of a matrix, find the determinant, because you need that, don't you? Swap the elements along the main diagonal, A and D. Swap these two. Change the signs of the elements of the other diagonal, BC. So make both of these negatives as we have there. Then divide each of the elements by the determinant. So as you can see here, we've gone D over the determinant, negative B over the determinant. And that's what's the same thing as taking this entire thing out the front and multiplying it by each of the elements there. Note, if you inverse an inverse matrix, then it goes back to the original. So the inverse of A, if you find the inverse of that, it just goes back to A. Now, before we move on, let's just take note of something very important. And that is, remember, when we were finding the determinant, what we said, and I'll scroll back to our notes here. Remember what we said, that if the determinant of A was equal to 0, then the matrix A was singular, which meant no inverse existed. So let's come here for a second, and let's imagine for a moment that AD minus BC was equal to 0. Okay, so you don't have to write this down. Don't write this down, but let's just imagine for a second my determinant is equal to 0. That means I'm going to end up with this, negative CA. Okay. Can someone tell me, what is 1 divided by 0? What is 1 divided by 0? Well, this is a notorious thing in maths. This is undefined. Undefined. Which means the whole thing doesn't work. It doesn't make any sense. So that's why if you get a determinant of 0, you can't find the inverse. There is no inverse. The inverse would be undefined. So that's why if you find that your determinant is 0, there is no inverse. All right. A lot of information there. Hopefully it all made sense. And I'll see you in the next part.